Hello, and welcome to episode 3 of our series Back to Basics, Season 2. Today, we are going to talk about expert systems and rule engines. Two topics very interesting in the machine-based decision support pillar. From Wikipedia, an expert system is a computer system emulating the decision-making ability of a human expert. Expert systems are designed to solve complex problems by reasoning through bodies of knowledge represented mainly as if-then rules rather than through conventional procedural code. Expert systems are the first artificial intelligence. Their principle is to gather expert knowledge on a topic, implement it as a set of rules used to take decisions. So an expert system is a software able to answer questions by executing a reasoning based on facts and rules. For example, a doctor will use facts and with his or her knowledge and experience will be able to identify an illness and provide a prescription. Can we give the same facts and gather the knowledge and experience from the doctor to infer the illness and the prescription? In a business context, financial consolidation is an expert system, with consolidation rules and the facts are the financial data. If we look at the history of expert systems, research in the 1960s and 70s led to the creation of the first expert system called Dendrel. Dendrel's objective was to identify components from a material based on their mass spectrometer profile. This system was followed by a medical expert system called EN, whose objective was to identify bacteria causing severe infections such as bacteremia and meningitis, and to recommend antibiotics. EN consisted of about 600 rules. In the 1980s and 90s, the much wider usage of computers has led to an increased usage of expert systems, which have been refined by using fuzzy logic, Bayesian networks, and neural networks. An expert system contains three parts: a fact base, meaning all we know about the topic; a rule base, meaning the list of all the rules to be applied; and an inference engine. The inference engine uses the facts, meaning the observations, diagnostics, etc., and uses the rules to, at the end, generate an answer to the asked question, which we will call the decision. Most expert systems are based on formal logic and use a deductive reasoning. They use the following inference rule, also known as syllogism. If P is true, and if we know that P implies Q, then Q is true. The simplest expert systems are based on what we call a proposition logic. We only use propositions which are either true or false. They have all the same value. More advanced expert systems use predicates and allow to address more complex reasoning, such as all human beings are mortal. Socrates is a human being. Socrates is mortal. However, it's very important to keep coherence in the rules. The following examples show potential problems. If A and B, then C. If A and B, then D, we have an incompatibility. If A then B, and if C then B, then we have redundancy, except if they have not the same certainty. Third example, if A then B, if B then C, if C then A, then we have a loop. More advanced ways of defining rules include fuzzy logic, where the boundary between true and false is not abrupt. There is a smooth transition between true and false because it's not always easy to define exactly where the transition is. And in reality, the transition is usually not sudden. For some values, the response is a bit true and a little bit more false, or vice versa. Inference engines are well known. However, determining the set of facts and rules that will constitute the knowledge base is a much more difficult job. It comes down to the description of the way an expert thinks, when confronted to a specific question, obviously. What is the mental process used to solve the problem? What we are looking to gather is the experience and not the theory that we could find in books. Research on how to acquire expert knowledge has led to developing specific knowledge acquisition methods. The most usual way of gathering expert knowledge is through interviews. The more complex the expert system is, the more difficult it is to understand how the system thinks. In other words, when expert systems have more than 100 rules, it becomes more difficult to follow the rules that are used, and therefore to set the system up, and more importantly, to maintain it. Maintaining an expert system means adding new knowledge, but if this is achieved through adding new rules, this may lead to incompatibility, redundancy, and loops, as we saw before. These should be, of course, avoided, so it requires a large amount of work to make sure the expert system works properly. One of the ways to counter this is to use machine learning to define the proper set of rules. This may lead to solving the complexity issue, but also to lose control over the expert system. In other words, we cannot understand anymore how the expert system thinks. Now that we know a little bit more about rule engines and expert systems, I will see you next time in the next episode when we will talk about reporting and analysis. See you soon.